Hi, my name is Chris Young, and we are Team Intterra. Intterra is a company that has created a software platform to provide real-time data analysis and data management services for fire departments nationwide, including 32 FDL, or Fire Data Lab clients. Fire departments struggle to empirically define the value of their service and often simply measure themselves against static benchmarks. In coordination with the Fire Data Lab, Intterra is using a live, diverse data set to measure department success and improve quality of service. Of course, fire departments across the country are as different as the communities which they serve. In this example, we see two departments that are clearly beyond comparison. Intterra wants to organize fire departments into cohorts based on the various features describing them. This context will allow departments to compare how well they provide services to their communities and explore ways that similar departments have improved their operations and outcomes. Our goal is to provide a tool for Intterra to explore ways of clustering departments based on a variety of different features.
We pull data from three primary sources. The first one is macro-level data about departments. This includes information regarding department budget, personnel, resources, and area served. Second, we pull CAD data. With computer-aided dispatch systems, first responders accumulate data on every incident responded to. This records data like the type of incident, time taken to respond, and whether the incident was an emergency or not. Third, we pull demographics data. We pull data from the American Community Survey to describe populations served by each department. Each census tract is broken up into smaller groups for which we obtain distributions of age, income, and education. By understanding the nuances of their population, a department can adjust their infrastructure and strategy accordingly. For example, if they know that older populations tend to require more EMS calls, they can identify older parts of their community and allocate the proper resources.
One key feature we engineered is station distance spread. We found that long response times can often be the result of how far stations are from the incidents. That is, if fire stations are too spread out, the average distance from station to incident can be long, causing a longer response time. We sought to answer the question, for each station, how far away is its nearest station? We averaged this distance to the nearest station for all stations in a department to output an average distance in miles. The result gives us some sense of the spread of stations in a department and provides much needed context to the standard response time metric. We then put all the features discussed before into our clustering algorithm. We chose hierarchical clustering because it yielded the most reliable results and also because the output is a more interpretable dendrogram structure like we see here. The result shown here includes all the features discussed before, but future applications can customize which features are chosen and how important each feature should be treated by the algorithm.
Our end users are fire departments, so it's particularly important for our results to be presented in a way that's easy to interpret. Here is an example of our final product. We see a query department, D, and its most similar department, J. For each department, we provide a radar plot summarizing their features, along with the breakdown of the department's incidents by category. The features are summarized into a radar plot using principal component analysis to group similar features chosen by the user. So in the example here, we see that the departments are both pretty average in their personnel and station spread. We also see that they are both different from average in incident types and size. We even see this reflected in the incident category breakdowns on the right. These departments both have a disproportionately high rate of false calls. Additionally, we can also see how these similar departments are also a little different by looking at the demographics axis. This is an example of how Intterra can use our results to explore comparisons between departments.
Our results provide Intterra with a tool to explore department clusterings based on different features. With their analysis, departments can identify who their peers are and exchange information to help fire departments across the country save lives. We want to thank the team at Intterra for all their support and encouragement over the past year. We also want to thank our D2K fellow, Daniel, for his guidance throughout this entire project.